Okay, very good evening to all of you. So, I'm Professor Ashmi Bade, and we are going to start with soil mechanics of Prerana scheme. So, here you are having certain topics in your syllabus: origins of soil, soil structure and fabric, three-phase system, and phase relationships, index properties, unified and Indian standard soil classification system. Since all these things have been studied in GT1, but now you are going to study again in this Prerana scheme. So here, soil mechanics is given by Professor R.G. Bade, Department of Civil Engineering, Anjuman College of Engineering and Technology, Nagpur. So what is the introduction? In introduction now, again I have given you what you have to study. So origin of soil, soil structure and fabric, three-phase system and phase relationships, index properties, unified and Indian standard soil classification system. So all this we have to study. In this some numericals will be there. So those numericals also we are going to study here online. So what is basically geotechnical engineering? We'll see it first. So what is soil? So soil is nothing but natural aggregates of grains, small particles, which may be loose, which may be dense, which may be moderately cohesive, inorganic, there may be chemicals or organic, fertile soil in nature that have the capacity of being separated by means of simple mechanical process. If you take some handful of soil and if you press it or just you break it, then it is broken into pieces by only mechanical process. So what is geotechnical engineering? A unique combination of science, experience, judgment, and a passion for understanding the uniqueness and variability of ground condition resulting from the forces of nature. It is very interesting subject. Unique combination of science. What does it mean, unique combination of science? Experience, judgment, and passion for understanding. It is very necessary that you should take keen interest in the subject. If you take keen interest in the subject, from science you get the results. When you do the experiment several times, you get the same result, then it gives you the experience that no, this is the result getting from the experimentation, so this is your experience. If you are calculating say bearing capacity of black cotton soil, you are getting it 100, 99, 100, 110, then you get an experience that the black cotton soil is having the safe bearing capacity from 80 to 120 to 150 only. So it is a soft soil. Judgment means from this science and experience you take one particular decision, and that is known as your judgment. And passion of understanding the uniqueness means you should have a keen interest in the subject and understanding. You should have a better understanding of that particular soil which you are going to learn. Variability of ground condition resulting from forces of nature. There are forces on the soil, those forces we have to study. Second is Second is it is the art of determining the properties of unseen and variable materials to provide a facility that performs as expected at acceptable level of risk and at an optional cost. What is the condition? It says that if you are having a soil that is very harmful, then you have to remove it and you have to add non-cohesive soil. But that should be optional. Matlab, the cost of that particular risk should be very nominal. So what is next? Application of civil engineering to the earthen materials. So for earthen materials means what? What are the earthen materials for a civil engineer? There is one soil, another is rock, and another is groundwater. So these are the three earthen materials for a civil engineer to deal with, which comes in geotechnical engineering. Then what is the difference between soil and dirt? So you should know very very clearly what is soil and what is dirt. That only you will be able to analyze the soil. So see what is written. If you can grow food in it, get paid to analyze it, or get college credit for paying with it, it's soil. Otherwise, it's dirt. It means that when you are having a soil, you are growing food in it, you are resting some structure in it, then it is a soil. But or otherwise, it is a dirt. Okay, it is a dirt, it is a dust. Then what is soil behavior introduction? So concrete and steel are textbook materials and soil is not. I think you agree with this because concrete and steel are textbook materials. What does it mean? From for concrete, if we get an example, you can have the IS codes and you can take the values from IS code. For example, if you are designing any structure by LSM method, limit state design method, then M15, M20, M30, they are defined. Okay. For steel also Fe415, Fe500, and steel structure, steel book is given to you. So these two, concrete and steel, are the textbook materials, but soil is not. You cannot say that safe bearing capacity of black cotton soil is so and so, sand is so and rock is so and so. You have to calculate it every time. Okay. So that's why you say that textbook material is not soil. They can be concrete, they can be steel, but soil is certainly different. Soil is very complex material. If you are changing 1 foot to another foot, from 1 meter if you are taking a soil sample and from 2 meter you are taking the soil sample, you are getting the two different values for that soil. So what is soil? Soil is heterogeneous. So soil is heterogeneous and soil is homogeneous. If soil particles are one and the same, then they are known as homogeneous. If soil particles are different, small, big, stones, etc., in that, then they can be said as heterogeneous soil particles. Then soil is non-conservative. Okay, if you see here, before you apply the load, the soil is like this. After you apply a little load, little pressure on the soil, it will try to compress. But if you release the load at an elastic value, then it will come to an original position. That means for very little load, soil is at elastic material also. That is known as your conservative soil material. But before, if the soil is like this, you apply larger load, then you remove the load, but the soil is compressed. How the load you have applied, the soil compressed, it won't come to its original position. Then it is known as soil as non-conservative material. But it doesn't mean that it's liberal. It's liberal means sometimes it may be elastic material, sometimes it may be plastic material. Then soil is non-linear. We can draw a stress strain curve by using UCS method. If you apply a small load, then it will be a straight line, linear load. That means soil is not going to a plastic state. If you remove the load, it will come to its original position. But when you apply the load, it will try to change its position. It will be straight, then it will become curved, and then it will break down. When soil breaks down, it will come down. So it is non-linear material, plastic material. Then what is soil formation? So soil formation is by weathering action. Now see, there are four stages. If you can see, in first stage there is soil like this. There are no plantation. When you apply some plantation, the roots will be developed at very small linear stages. Then when these plants are growing, the roots are growing more, and the roots are forcing these soil particles in a downward direction. Again, when the trees are developed, the roots grow very, very fast in a downward direction, and they push their soil particles in a downward motion. So what is soil formation? Weathering is the process of breaking down the rocks. So these rocks are broken down into soil particles. Now you can see that the rocks have been developed into. In physical weathering, breakdown of rock is done, but it's made of stays the same. Made of stays made this. What does it mean? It means that their position of rock is same. They are broken into small rock pieces only.
Okay, good morning, class. Today we are going to learn about the basic characteristics first. So, first is your particle bonding. So, particle bonding means grain to grain of soil should have a very good bonding between them. So, how this happens? The particle bonding is very weak. Very good bonding between them. So, what we have to do? The particle bonding is very weak, very good bonding between them. So you have already seen. What we have to do? The particle bonding is very weak, very good bonding between them. So you have already. So see what is written. The particle bonding is very weak, so relatively easy to going to change and have non-linear behavior and characteristics. And second is shape, size and structure of soil particle. So first is your bonding. So in this bonding, you have to see whether if their bonding is weak, relatively weak, or having strong. And non-linear means that the bonding is in elastic condition. That means if you are applying the load, then there is elastic bonding, and when you release the load, the body is coming to its original position. But non-linear condition is that when you apply the load and remove the load, the body will not gain its original condition. And next is your shape, size and structure of soil particles. So there are two types of soil. One is cohesive soil and another is non-cohesive soil. So cohesive soils are very prominent for swell shrink property, such as black cotton soil is the example. If you add water, it will swell. If you remove water, it will shrink. And non-cohesive soil such as sand, if you add water, it will drain out water, it will not swell. And you remove water, it will not shrink. So these are the two types of soil. So these are the shapes of soils. First is angular, second is subangular, subrounded, rounded, and the position is like dispersed and flocculated. Dispersed means face to face connection. This edge to edge connection means this edge is connected to this edge is connected to this edge is connected to this edge. To dispersed condition is edge to edge connection, and flocculated means edge to face connection. So this is your first line and grain, and this is your second. So this edge is connected to this face, this edge is connected to this face. So this means that flocculated particles are face to edge connection. Now second is your soil fabric as mentioned in your syllabus of GET. The soil fabric is of two types, dense and loose. So if you see the arrangement of the soil particles like this, so you can see that the innermost blue color shows that the voids in this condition is very less. And if you see the loose sand condition, then you can see these blue type voids, they are in larger condition. So loose and then conditions are there. So arrangement of soil particles should be in such a manner, compaction in such a manner that the voids are very less. Next is your physical properties of soil. So we'll see some basic definitions and phase relationships. So first, soil, water and air. In this diagram, the black color is soil solids, and white color is water, and ash color is air. So here your volume of air, volume of water and volume of soil solids is given. If you compare this volume, mass and weight, then you can see this volume is given as Va for air, Vw for water, Vs for soil solids. Mass and weight for air is 0, but water contains Mw and mass Ms. And here WW and Ws for water and soil solids. Next, these are the units we have already studied. length in meters, mass in tons, density tons per meter cube, weight in kilonewton, stress in 1 kilonewton per meter square, unit weight kilonewton per meter cube, and accuracy can be measured rho W equals to 1 ton per meter cube. Now, what is geotechnical engineering? Since we are considering the geotechnical engineering, then what conditions civil engineer has to face? A civil engineer deals with properties, behavior, and use. Now, what are these properties, behavior, and use? For this, what your conditions are earth materials, properties, behavior, and use of what? Earth materials. So, what are earth materials? You have to see that in soil mechanics. There are integrated knowledge from where you have to take. So, properties, behavior, and use of earth material requires the integrated knowledge from where. So you have to search it from where you have to get. So first is your geology. You have studied in third semester. Then material science and testing. Then mechanics and hydraulics. Then environmental science and engineering. All these are coming in your earth material. Then where this knowledge is applicable, whatever you are doing has to be applied in the field. Application is very necessary. So where you are applying this knowledge, the knowledge and their application is required for what? Anyone can tell? Anyone of you? It is required for foundation. Okay, to design the foundation and retaining structure. The application is required for what? So the application is required for design. For designing of what? Foundation, retaining and earth structures. Foundation means wherever there are buildings, high-rise buildings, any malls, any public buildings, commercial buildings. So you are having foundation, shallow foundation and deep foundation footing. So there you require the application. Then retaining and earth structures. So retaining walls are given in the pavements and the slopes where you are having the basements. Then water dams. There are the embankments. There these retaining structures are there where you require this type of application. Then let us study what is the scope of soil mechanics. In which subject you require soil mechanics, which is very important. So first subject is embankment, excavation and dam. So it requires the knowledge of slope stability involving soil behavior for dams considering seepage problem. Whenever embankment and all is there, there will be slope, and with the help of slope, the water will try to seepage down, and therefore there will be the seepage problem. Next is your pavement design of rigid and flexible. Rigid pavement is made up of concrete and flexible pavement is made up of tar. So rigid and flexible pavements both depend on the behavior of subgrade of soil. So there you have to see the how much the soil is going to settle it, if it is a cohesive soil, how it will swell, what will be the repeated load, and in northern side, if there is frost action, how the heaves are developed. So all these conditions you have to see in pavement design. So next, the development of soil mechanics. Any guesses? Development of soil mechanics. So before 18th century, no documentation, systematic manner was there. Okay, no knowledge was there before 18th century. Then list of recorded events since 1776. Then in 20th century, soil mechanics received much attention and disseminated various publications. That means in 18th century, there was no documentation, there was only thumb rules and experience, and the foundations were made. Then list recorded that this study is to be study. Then in 20th century, it came into attention and various publications were made that this subject has to be studied further. Documentation work of geotechnical by Skinton in the Scientist publications in 1979. Then father of soil mechanics. Who is father of soil mechanics? Why we call them father of soil mechanics? Any one of you? Any guesses for father of soil mechanics, students? Okay. It was Carl Terzaghi who made certain formulations, who has done so many investigations and have given some concrete decisions, some concrete foundation materials, some theories regarding soil which came into existence. Then what is soil? Everyone knows soil. We are every day study the soil. We travel on the soil pavements, है ना? तो सॉइल सबको मालूम है, सबके घर में पेड़ पौधे लगे हुए हैं. तो सॉइल जो है वो किसके लिए यूज होता है? ठीक है, हमारे लिए कैसे यूज होगा सॉइल? How will like to do it? How you are going to do that soil? Okay. So the term derived from Latin word solium. Okay. So solium is what? It is the upper layer of the earth crust that may be dug or plugged. Kindly go through this first, then I will explain you. First, it is the uppermost layer of the There are three diagrams. Kindly go through these three diagram, please. One is given by geologist. जियोलॉजिस्ट में अपर के दो लेयर है वो सॉइल कंसीडर किया जाता है. देन एग्रोनॉमिस्ट दे आर सेइंग दैट सॉइल का अपर एक पार्ट होता है, बीच में रॉक होता है और नीचे सॉइल सॉलिड्स होता है. ठीक है. और नेक्स्ट जो होता है जियो Okay, so again, good morning, students. We are starting with the soil as a three-phase system. If you can see this diagram, this is the original diagram. If you take a handful of soil, then you will have some soil solids, then you will have some air, and then you will have some water. So this is your air, and this white color is water. So liquid phase and gas phase. So there will be some air, there will be water, and there will be soil solids. Then how the formation of soil is done. So first you have done geology. So what is given? Disintegration of rock, then decomposition of organic matters. So what does it mean? You have already studied. Disintegration of rock means the parent rock is having certain weathering actions, and with that chemical weathering actions, the parent rock is disintegrated or broken into small types of stones. Then decomposition of organic matters. Organic matters, vegetative matters, are there. They are growing in trees. When they grow in trees, the trees roots push the rock by disintegrating in them into small soil particles. Then what is rocks? So rocks are of three types. One is your igneous rock, second is your sedimentary rock, and third is your metamorphic rock. Then what happens? The rock weathering is happening. When rock weathering is happening, what you get? You get mineral grains. From that mineral grains, what is happening? You get a three-phase system. You get air, you get water, you get soil solids. In soil solids, you may also have the decayed organic matter. So this is how the soil is formed. Now, soil forming rocks. So what is soil forming rocks here? So there are certain points. So let us go one by one. So first is your rock, outer rocky shell or crust of the earth. That means it is the uppermost part of the parent rock, a big parent rock, which is known as your outer rock shell or crust of the earth. Earth means soil. Rock is also soil for us. Second is your igneous rock, which is obtained from cooled from molten state when lava goes inside the sea. Then the big rocks are formed, and those are known as igneous rocks, which is known as cool from molten state. That means lava is cooled, and when they are cooled, they become a stone. So for example, they are granite, they are diorite, they are ballast, etc. Then sedimentary rock, deposit from a fluid medium. Sedimentary rocks are again very sandstone, limestone, and shell. They are very brittle. If you break it by hand also, they will break. Metamorphic rocks, they are from igneous and sedimentary rocks. Okay, they are pre-existing rocks by the action of heat and pressure. So quartzites, schist, and slate are the examples of this. So what is the geological cycle? In geology, you have already studied what is geological cycle. So first is your parent rock. When millions of years happen, parent rock disintegrates, and when parent rock disintegrates, it becomes soil. Again, the deposits of soil is there, and again the parent rock is made. So this is the cycle. Rock, millions of years it will become soil. Again, millions of years it will become rock. So this is geological cycle. So there are certain points. What are those? Modify the earth's surface, destroy old rocks, create new rocks, add complexity to the ground surface, and which forms the soil. It modifies the earth's surface, destroys old rock. Means this is the rock, it destroys the old rock by weathering effect. Then they create new rocks. When soil is formed, again new rock is there and add complexity to the ground surface and then forms the soil by weathering actions. Next is introduction to geotechnical engineering. Kindly see the diagram. All civil engineer begins with the geotechnical engineering. If you see that this is some certain type of a structure which is resting on the ground. So this is the soil which is used for foundation material. Here the ground means this soil is used as foundation material. Then what happens? Typical geotechnical project. Okay. So first what happens? What is happening? First, the soil, you dig the soil samples are taken to the geotechnical laboratory for testing. Then some properties are obtained from this geotechnical laboratory, soil properties. They are given to the design office for design analysis. Design and analysis is done when details of design are coming to the construction site, then the construction of the structure begins. So this is the construction process. First, soil to the geotechnical lab, obtaining the properties, designing it, and design is transferred to the construction site, and then the construction is done. Then what are shallow foundations? So shallow foundations and deep foundations, there are two types. Kindly have a look in the diagram. Shallow foundations for transferring building loads to the underlying ground. ठीक है, ये firm ground है, ये आपकी building है और this green type of thing is the foundation, mostly for firm rocks or light loads. If there is a rocky soil, if there is a firm soil, you are getting concrete materials, rocks are available, hard strata is available, then you give the shallow foundation of this type for any small constructions or big construction. So this is some example of shallow foundation. These are white footings and these are coming out of this. These are now design of shallow foundation system and bearing capacity failure. Transconal grain elevator. This was the construction done on the soft soil in from Budu to This was the construction done, and because the bearing capacity was not so taken in down, okay, only because the bearing capacity failed. Now foundation system. Kindly have a look on this diagram, on this picture. So this is the Leaning Tower of Pisa. So designing of shallow foundation system, this is differential settlement. There are two types of settlement. One is your equal settlement and another is your differential settlement. Here you can see that uh, the original position, if you can see the line of original position, if we draw the straight line, ठीक है, अब ये इतनी तो straight नहीं बन रही है मेरे हाथ से, but if you draw the straight line of the foundation, you can see that there is an tilted angle, यानी कि इतना ज्यादा tilt हो गया है आपका leaning pisa. So ये जो angle है, ठीक है, ये जो angle बन गया है, so this is because of differential settlement. That means here the soil is getting so soil has failed. ये यहाँ की soil जो है वो थोड़ा सा ज्यादा दब गई है, compress हो गई है, जिसकी वजह से ये tilt हो गया है. Okay. Now deep foundations. For transferring building loads to underlying ground, most for weak soils or heavy soils, we are giving this piles. Piles are of two types, frictional piles and end-bearing piles. If you are having a bedrock here, अगर आपको यहाँ पे bedrock है तो आप यहाँ तक के पाइल को ला सकते हैं, लेकिन अगर आपको पूरी वीक सॉइल मिल रही है तो एक पर्टिकुलर लेंथ तक आप वो पाइल को लेकर आ सकते हैं. ठीक है. When there are heavy loads you have to and weak soil, then you have to consider pile foundation. So foundation system, these are the driven piles. Piles are driven by this type of tamping rods. So this is an auger. First you drill the soil, then you insert the cage of the pile, and then you do the concreting in this pile, drill shaft. So what are the retaining walls? The retaining walls are the soil for spreading laterally. So these are the retaining walls. If this is a tunnel and it is a road or a train, then these are the retaining walls, and upper side also there is a road, then these are the retaining walls. We should not slide inside. So these two are the retaining walls, and this is the slab which is constructed over the soil. So earth pressure and retaining walls. So there is the soil over here. So this is a retaining wall which is provided for this road. This is a retaining wall. Here also there is a there is a soil here, there is a slope here, and there is a again one construction flyover over here. So this is a retaining wall provided to stop the soil slide here. Again, these are the gabions. These are made up of stones, small stones. No concrete is used for this. This is the soil material, so this should not slide down here in the road. So these gabions are given here. Again, here is the road. Again, this gabion is given here, and the train is going from upper side. So this is soil nailing, this is the retaining wall, and by inserting the steel rods inside this construction, which is known as your soil nailing, here beside this retaining wall there is a soil. So this soil should not push this retaining wall. That's why the soil nailing is done inside. The soil this nails will from this retaining wall will go inside the soil. So these are the sheet piles. If there is a ship over here, there is a construction over here and ships are moving, this is water level. So what will happen? You have to give some sheet pile here which is anchored at some level, because sheet pile is a slender member and it should not buckle. Okay, what happens? The soil is a slender member, so it should not buckle like this. ये buckling should not be there. Okay, so when buckling will happen, the sheet pile will fail. So this anchor is given here so that it will remain straight. So this is how the sheet pile is taken care. These are again the sheet piles. Whenever you are constructing any structure here, these sheet piles are constructed in this river bed for stopping the water coming inside here, and then the construction is done. These are the sheet piles again here. These are sheet pile walls in a zigzag manner. If you can see, then water will not get inside the construction material. This is how the construction is done. These are the tunneling. Now earthen dams, if water level is here, for impounding water, this is the clay core and this is the shell and this is the soil. Then weight and unit weights. Force due to mass, weight more important than mass. So what will be the weight? Anyone? So weight will be equals to mg. Then unit weight is there. Then unit weight gamma. Bulk unit weight is given by W upon V. Weight upon volume, which is mass into G upon V. Therefore, gamma is given by rho into G, where M by V is your rho, density of soil. Then, when you are having some small element and there is a vertical stress here, so how the vertical stress is given for the Z height, we don't know how much height is there, where is the hard strata. So the stress in vertical direction is given by rho gz and sigma v equals to gamma into z, where gamma is the, what is gamma? Unit weight of soil. Then specific gravity. So specific gravity G, it is given by density of material upon density of water, rho upon rho W. So G also in unit weight of material upon unit weight of water, which is given by gamma upon gamma W. Gs is approximately equals to 2.65 for most of the soils. Gs is useful because it enables the volume of soil particles to be calculated from mass or unit or weight. So what will be Vs? Volume of, this is Gs required, Ms upon rho s, mass of soil solids upon density of soil solids, which is given by mass of soil solids upon rho is again Gs into rho s, which is given by M upon G, M upon rho gives W upon gamma, where Ws upon Gs into gamma W, where gamma W is the unit weight of soil. Then voids ratio. The voids ratio is defined as Vv upon Vs, where Vv is the volume of voids and Vs is volume of soil solids, and porosity is given by Vv upon V, where Vv is volume of voids and upon total volume. Then relation between this is given as Vs is equals to total volume minus volume of voids equals to 1 minus porosity into volume. So if you solve all this, then you will get E will be equals to N upon 1 minus N. Then degree of saturation, it is the ratio of volume of water upon volume of voids. So if you do all the examination, so if you do all this, we have already done this expression in GT1, when you solve all this total derivation, then you get SR equals to WG upon E. Remember that if on the voids may be filled with air or water or both. If air is present, then soil is dry, and when the degree of saturation is 0, SR is 0. On the other hand, the voids are filled with water and the degree of saturation is 100. So sometimes it is dry and sometimes it is 100% saturated. Air contained, again it is given to you. I think this is the we'll do in next class, because it is quarter to 11 and your next class will start with 11 o'clock. So thank you students for attending the class. Whenever I will take the next class, I will inform you again. Thank you so much. If you have not followed anything, if you have any queries, you can just call me. My number is with you. Thank you so much. Any questions you can pen down. You can write down in the chat box. or you can just pen down in the WhatsApp number.